Okay, let's finish up 2.3 with this word problem. Let's read the problem. The school has just purchased new computer equipment for $25,000. The graph shows the depreciation of the equipment over 5 years. The point 0, 25,000 represents the purchase price, and the point 50 represents when the equipment will be replaced. So let's mark those 2 points. I have this point 0, 25,000. And I have this point, which is 5, 0 that they've given me. We want to write a linear equation in slope-intercept form. Remember, slope-intercept form is y equal mx plus b. That models the value of the equipment, y, x years after the purchase. We want to use the model to predict the value of the equipment after 2 years. So let's start off trying to find the equation. It's y equal mx plus b. We actually already know b because it's the y-intercept, and that's given to us right here. That's my y-intercept. Remember, it has a 0 in the x position. But we don't know the slope. So let's come on the side and find the slope. Well, I need to know 2 points to calculate my slope, and I have my 2 points over here. So let's use this point and this point to calculate our slope. y2 minus y1 will be 0 minus 25,000 over x2 minus x1, which will be 5 minus 0. So negative 25,000 over 5 divides out to give me a negative 5,000. So there is my slope. So I can now write my equation of the line. Y equal negative 5,000 x, y equal mx plus b, which is my y-intercept, which was found to be 25,000. So there is the linear model. Y equal negative 5,000 x plus 25,000. Notice the slope is negative. That means we have a falling line. Slope is negative. And finally, last thing is, let's use this model to predict the value of the equipment after 2 years. What that's telling me is I'm going to let x be equal to 2, find out what y is. Let's come in here and put a 2 in place for x. So negative 5,000 times 2, we get negative 10,000 plus 25,000 gives us a value of y equal 25 minus 10, which would be 15,000. So we use this model to predict what would happen after 2 years, what would be the value. Let's look at the graph. Here is the number 2, where x is equal to 2, it's my x-axis. At 2, where does it look like we have a point? There's 2, there's my point. Yep, looks like it's really close to 15,000, so it does a pretty good job of predicting. Actually, I should have gone a little bit further left. But the equation does a really good job of predicting the depreciation, or the value after so many years. So that's it. You've got the assignment here to look at. You've got an application problem, a critical thinking problem. Go to Math Excel, do the homework, and then make sure you look at these 2 problems in the book.